Hello. I think I told all of you this on Friday, but I have a meeting today, so I will not be in the class. But luckily, we aren't doing really anything new. We're just talking about all of the methods that we've done so far, and then the best times to pick each one. Notice graphing is not a choice. So when we look at this, it's just giving us factoring, square roots, completing the square, and the quadratic formula. Graphing probably will be an option on your test, but it's never really the best option. So we're focusing on these other ones today. So over here, there's just some notes regarding when each of these are best used. So factoring, obviously, you can only use when the equation is factorable. So sometimes you can't factor things, and we'll talk about that a little bit as well. So this, I'm going to write the width of my pen got really weird. So we want to use factoring when the equation is factorable. In other words, when it's one of those factoring types that we've done before. So square roots, you can use square roots when there is no bx term. So when that x term is missing, which we have talked about before. So both of those methods do not work all the time. Now these final two methods do work on every single quadratic. So completing the square is best used when a equals 1 and when b is even. Otherwise, it's probably not the best option. And then the quadratic formula, I would say let's use in all other cases. Says, when is it factorable? So the quadratic will not always be factorable. If it's a factoring kind that you recognize and you're given the choice, you're welcome to factor it. If you can't tell if it's factorable, there is an equation that will always tell you if it is. We talked about this a little bit last week, but when you do b squared minus 4ac, like the part of the quadratic formula under the square root, if that's a perfect square, then it's factorable. So it is factorable when b squared minus 4ac is a perfect square. So down here it says choose a method and solve each equation below. You can only use each method once. Okay, so we're looking at all of these. What I like to do first is just visibly kind of look at them and see if any of them are easy to factor. So just looking at them for a minute, it looks like number 4 is actually one of those factoring kinds that's a little bit simpler. It already has a 0 on the right side. And then on the left side, there's no value in front of the x squared term, which means we can use that rule to factor it. We can say what multiplies to 14. So we want them to multiply to 14, and we want these numbers to add to 9. So multiply to 14, add to 9 would have to be 7 and 2. So I'm going to write x plus 7, x plus 2. So therefore my zeros are x equals negative 7 and x equals negative 2. So those would be my answers. Remember, you don't have to write x equals twice. That was factoring, so I'm just putting an x next to this. We already used factoring, so that's not an option for the other ones. These are just the abbreviations for square roots, completing the square, and then the quadratic formula. Okay, just looking around here. Number 2 looks like a great one to use square roots on. If I were in the classroom, I would have you tell me why. But if we look above, square roots, it's possible when there's no bx term. So this one has no x term, so we can definitely use square roots. So to use square roots, you always want to isolate the squared part. So you have 9x squared equals 4. You want to divide by 9. Some of you are trying to take the square root before you divide by 9, but you want to get that squared part alone first. Then take the square root. No need to use a calculator on this actually, because you can just square root the fraction. So the square root of 4 is 2. The square root of 9 is 3. So it'd be plus or minus 2/3. And on that one we use square roots, so I'm just crossing off square roots because it does say we can only use each method once, like in the directions. Okay, neither of these other ones are in standard form, so it's a little bit hard to tell if they're factorable. Plus I already used factoring, so for this particular time it's not really an option anyway. So we're using completing the square and then the quadratic formula. So completing the square is always easier when there's no number in front of the square term. Remember, if there is a number there, you have to divide by it. This number 1 has no number in front of it, in front of the squared term, so I'm going to use completing the square on this one. So to use completing the square, we move the 7. So we have x squared minus 6x equals 73 minus 7. And then we get 66. Then we want to complete the square. So to complete the square, which I usually write CTS, we take half of the x coefficient, so in other words, the number in front of x. So half of negative 6 is negative 3, and then we square it. So we get 9. So we're going to add 9 to both sides. So we have x squared minus 6x plus 9. 66 plus 9 is 75. Factor the left side. Remember, whenever we complete the square, it's going to be the same factor twice. So your setup is like this. This number is always half of this b value. So it's negative 3. Then just solve for x. So get rid of the squared. X minus 3 equals plus or minus. The square root of 75, I'm going to approximate. So we get 8.66. Solve that for x, so add 3. So we get x is approximately equal to, this should be approximate too actually because I rounded, positive 8.66 plus 3 is 11.66. Negative 8.66 plus 3 is negative 5.66. So those are your two solutions there. That means the only one that I have left as a choice here is the quadratic formula. So I have to use the quadratic formula here. So I'm going to get a 0 on one side. Quadratic formula is, which hopefully we all have this memorized by now, just writing it over here. In case you don't have your notes out and don't know it, just make sure you know it by Friday when that's your test. So the opposite of b would be negative 8 because b is positive 8. Sometimes I like to write out a, b, and c first, so I will do that. A is 2, b is 8, c is 7. So write out a, b, and c, and then plug into the quadratic formula and then follow those simplifying steps. So the opposite of b would be negative 8 plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So then I typically type the thing underneath the root, which does have a name actually. It's called the discriminant. You'll talk more about it in Algebra 2. But I type that into the calculator, and in this case, when I do that, I end up getting 8. 2 times 2 is 4. Then we approximate the square root of 8. So I'm actually typing the square root of 8 in my calculator right now. I'm getting about 2.8. 1 decimal place is fine. So it's negative 8 plus or minus 2.8 over 4. So then we just separate that, and we do negative 8 plus 2.8 over 4. And then we do negative 8 minus 2.8 over 4. I'm kind of running out of room. So then when you type those in the calculator, you do need those parentheses. So I'm typing negative 8 plus 2.8, or do it in more than one step like we talked about last week. And then divide by 4. So for the plus one, I'm getting negative 1.3. And then when I do negative 8 minus 2.8, and then divided by 4, I'm getting negative 2.7, approximately. Those are to the nearest tenth, so just 1 decimal place. Okay, so that's one of each kind, just to review that process and talk about when we would pick each kind, because that is a good skill to have. So let's see, these ones we are choosing our own method. To be honest, I don't know if I'm going to do all of these live, but I will upload the key to Google Classroom. You have many notes with examples of all of these. Remember, all of the solving notes are the Chapter 9 notes, and if you don't have them, they're all in Google Classroom. But I'm just going to kind of talk you through some of these. I'm going to look through these and look to see if any of them are good for square roots. So I'm looking to visibly see if any of them are missing the x term. So actually number 11, it does not have an x term. So we're going to add 16 to both sides. So we have 6x squared equals 48. We're going to divide by 6 because we want to isolate the squared part. And we have x squared equals 48 divided by 6, which is 8. And then we're just going to square root it. So you get x equals plus or minus, and we're actually approximating that. So the square root of 8 is, hold on one second, square root 8, about, oh yeah, we just did that, sorry. It's about 2.8. So the answer is plus or minus 2.8. Okay, none of the rest of these actually work for square roots, which is kind of sad because that's the easiest one. So then visibly, and again, they don't work because they all have an x term. So then visibly, I kind of look for ones that look like I could factor them. So like number 7, for example, number 7, it looks like I can factor a 5 out of the whole thing. So I'm going to divide by 5 on everything, and I'm going to get 5. That 5 kind of stays in front. X squared minus 3x minus 10 equals 0. Factor x squared minus 3x minus 10, multiply to negative 10, add to negative 3 would be negative 5, and then positive 2. That 5 just hangs out in front. The solutions are the zeros of each factor, so the 5 doesn't impact the zeros. The 0 of x minus 5 is positive 5. The 0 of x plus 2 is negative 2. So those are your two answers. Trying to see if anything else is factorable. Remember, you can always find that, like it says on the first page of your notes, you can find b squared minus 4ac, and if it's a perfect square, something that you can square root, then it is factorable. Oh, number 8 is factorable. It just has a squared and an x term. Those are always factorable. So remember, we want to get a 0 on one side, and we want to do that so that the squared term stays positive. That's always a good idea when you're factoring. For the quadratic formula, it doesn't really matter, but for all of the other methods, keep that squared term positive. This is the GCF kind of factoring. And I'm glad I did this one because it seems like this has been a struggle lately. The greatest common factor of these is 9x. So divide by 9x, we get 4x minus 1. Set each factor equal to 0 and solve it. 9x equals 0. Divide by 9. We get x equals 0 because 0 divided by anything is 0. This 4x minus 1 equals 0. Remember, there is a shortcut. It's going to be the opposite of this number. So like positive 1 divided by 4. But if you can't remember that, just solve it. But you're going to get 1/4. So your two solutions for x are 0 and 1/4. Notice I have not been consistent about how I write that because it really doesn't matter. You don't even have to write x equals. You can just write 0, 1/4. Here I wrote x twice on number 7. On number 8 I didn't, but it's okay. There's kind of some freedom in that. Trying to look to see if anything else is factorable. I don't really think anything else is like easily factorable. Number 6 looks like it's probably that like tricky kind of factoring. So on number 6, you're looking for numbers that multiply to negative 20 and add to positive 1. I actually am going to do this one by factoring. But if you don't like this, then just do it by the quadratic formula while I'm talking about it, because we should get the same answers. I'm going to do it by factoring though. So multiply to 10 times negative 2 is negative 20. Add to positive 1. So the two numbers that multiply to negative 20, I'm just writing that down. You don't need to. And they have to add to 1. Is positive 5 and then negative 4. So change this middle term to plus 5x and then minus 4x. And then we factor by grouping. Or if you're doing the quadratic formula, just keep doing the quadratic formula. I would not do completing the square here, and then square roots is not an option. So the greatest common factor of this first group is 5x. The greatest common factor of the second group is negative 2. Take out the negative. That stays in front, and you get 2x plus 1. The GCF always stays in front. And then here we get 2x plus 1 when we divide. Remember, these like have to match. If they don't match, we did something wrong. So one of our factors is that one that we have in common, and then the other one is the like things in front of it. So 5x minus 2. Remember, there is a shortcut to figure out when that times that would equal 0. In order for that product to equal 0, one times the other, one of them has to equal 0. So you can set each one equal to 0 individually and solve it, or there is a shortcut. It's always the opposite of this number. So the 0 of this first factor would be -1 divided by the coefficient of x, which is 2. The 0 of the second factor, the opposite of -2 is +2 divided by the coefficient of x, which is 5. So those are your two zeros. Okay. Number 5 to me looks like one that's good to do with completing the square, so I'm going to do completing the square. It's already in the format I wanted in for completing the square. So take half of b, you get -1. Square it, you get +1. So add 1 to both sides. So that's what I have when I add 1. And then I'm going to factor the left side, multiply to +1, add to -2. Remember, there's a shortcut where this number is always half of this number. And then just follow those algebraic steps. By the way, if I'm going too fast for you, if you miss something, if it needs to be paused, you can ask. Also, this is on Google Classroom, and I will upload a key later too. So here we get x minus 1 equals plus or minus the square root of 5. The square root of 5 is approximately, hold on, I'm typing in the calculator, it's going to be 2 point something. Let's do to the 10th, so 1 decimal place. So about 2.2. Oops, I don't know what happened there. Solve that for x. Oops, I forgot my plus or minus, which does matter. So to solve this for x, we're going to add 1. Positive 2.2 plus 1 is 3.2. Negative 2.2 plus 1 is negative 1.2. You have a choice here. So like if you don't like completing the square, nothing says that you have to do it that way. It literally says using your method of choice. So you could do the quadratic formula. I feel like a lot of you like that better. I'm just trying to like demo all methods, but you do whatever you like best. Let's see. These other ones, I honestly would probably, let's see, number 9. I actually think that that's factorable. Whenever the squared term is negative, I factor a negative out. In other words, you change all the signs. Multiply to positive 63, add to negative 16 would be negative 9 and negative 7. Those negative 9 and negative 7 multiply to positive 63 and add to negative 16. If factoring is hard for you and you have the choice, don't do factoring. Do the quadratic formula. Factoring is faster if you know how to do it, but if you don't know how to do it and you have the option, then do the other thing. Do the quadratic formula. So let's see, the zeros of this, remember this negative in front does not impact the zeros. So the zeros are positive 9 and then positive 7, the opposites of those. Just kind of visibly looking to see if I see anything else that might be done without the quadratic formula. The quadratic formula honestly is not like my preferred method. I would rather factor square roots if I can. I tend to only use the quadratic formula if I have to. So like number 10 and number 12 look like they're probably not factorable. So on both of those, I would say use the quadratic formula. We've done the quadratic formula quite a bit lately, so I don't know that I need to write both of these out. So I'm going to do one of them with you, and then I will upload the key to all this later. So I think I'm going to choose to do number 12. Remember with the quadratic formula, it really doesn't matter if a is negative, so you can move whatever term you want to. So I'm going to move the squared term. If I were trying to do any other method, I wouldn't want that squared term to be negative, so I would move them to the other side. And then we're just plugging into that quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So I'm going to give you a minute. I know I wrote that kind of fast, to plug that into the quadratic formula. The next thing I always do is type this in my calculator. So I'm doing that right now. I suppose I could try to do it in my head, but that's not necessary. So let's see, I end up getting, looks like it's 128 for that thing under the root. 2 times negative 4 is negative 8. Approximate the square root of 128. So in other words, type it in the calculator. We get 11.3. Oops. Sorry. So you get -4 plus or minus 11.3 over -8. Okay, then you have to type it in the calculator. Be careful with those parentheses. You always need parentheses if there's more than one thing on the top or the bottom. So the top certainly has more than one thing. The bottom does too. The negative and the 8 count as 2 things. So type -4 plus 11.3 divided by -8. Oops, I typed it wrong. -4 plus 11.3 divided by -8 is -0.9, about 0.1. And then -4 minus 11.3 divided by -8. Oops, typed it wrong. I forgot the parentheses. Is about 1.91. Oh, I don't know why I'm doing hundredths. I guess I was only doing one decimal place. So if you want to just say about 0.9, I'm going to erase those ones just to be consistent. Okay, and then we basically did all of them. The only one that I didn't do is that last one. I would also use the quadratic formula on number 10. I will upload the key, and I will upload this video. Your homework, the sub's going to pass it out now, looks very similar to this. And then I will see you tomorrow to work on the study guide, both Wednesday and Thursday. That's your test review. And then your test is on Friday. Your test covers chapter 8 and chapter 9. So it's kind of a lot of material, but you'll kind of see how it's going to be formatted and all the stuff on it on tomorrow. So I will see you then.